Today we're going to be outlining the new DLI Control Program. Click the button to start. Introduction. The following topics are covered in this video: using the DLI Control Program, lighting zones, values, DLI Control Module components, DLI target, light sensors, DLI calculations, shutdown and restart settings, summary, and a short quiz. Using the DLI Control Program. This program is a control application designed to automatically operate supplementary lighting equipment to achieve a specified DLI, or daily light integral, in a mixed ambient supplementary lighting environment, typically a greenhouse. It does this by predicting the maximum possible natural DLI achievable based on the current date, geographic location, the sunlight transmission efficiency at the crop level. It then operates the lamps as needed throughout the day whenever the program predicts that the current DLI target cannot be achieved from sunlight alone. The program can control up to 4 supplemental lighting zones based on the amount of light already received and the amount of light likely to be delivered through the remainder of the day. Each zone is controlled by a separate DLI Control Module. There are 4 DLI Control Modules in each DLI program. Light modeling information is provided by a separate seasonal light intensity model program configured for the current location and time. Additional programs can be added as required. This model produces 3 values of interest: total potential sunlight, remaining potential sunlight, calculated intensity, or the sine curve. These values represent the ideal unobstructed outdoor light intensities that would occur for the set geographical location, the current or offset day of the year, and the time of day. Scaling factor, or transmission efficiency, settings are provided in the daily light integral program to compensate for the reduced light transmission of the greenhouse glass or plastic, which is typically below 40%. The daily light integral program only turns the artificial lights on if the light sensor reading is below a set cutoff threshold, and if the remaining potential sunlight isn't sufficient to achieve the desired DLI target. There are many settings available to control or influence when the artificial lights need to be on, including 7-day surplus deficit amounts that can adjust the DLI target, thereby averaging the DLI over several days. Many greenhouse crops respond well with a 2 to 4 day averaging. For example, if you have very good DLI for 2 days and then a poor DLI day, the average DLI over the 3 days may mean that no artificial light is necessary. Time window settings control when the lights can turn on. Output minimum on time and minimum off time settings to prevent short cycling the lights. Photo period settings to assure minimum day length. External overdrive to force the lights on or off. A close enough setting to prevent the light switching from off to on if today's DLI is within a set percentage of the adjusted DLI target. A preference setting, DLI accuracy versus cost savings. If the model indicates that the total of the predicted natural light plus the lamp potential before sunrise and after sunset is not sufficient to achieve the DLI target, when set to DLI target, not as important as cost savings. When set to DLI target, more important than cost savings. If the model indicates the total of the natural light plus the lamp potentials before sunrise and or after sunset is sufficient to achieve the DLI target, turn the lights on in the pre-dawn hours to make up for as much of the deficit as possible. If the model indicates that natural light alone is sufficient to achieve the DLI target, the program runs purely reactively. In addition to the basic algorithm used for achieving the DLI target, there are a number of limits and overrides that can be configured to constrain the operation of the lamps. These actions take priority over DLI lighting calculations and include, in order of precedence, lighting output state, external override, supplementary lighting window, photo period override, DLI cutoff threshold. The control module is used to set up a predictive DLI calculator for controlling the operation of supplemental lights. The final result is the desired output in the lighting output section, used to operate the supplemental lights. The desired output is determined by comparing the day's accumulated DLI to the target DLI and the probability that the DLI target can be achieved with sunlight alone given the remaining daylight available. DLI Control Module screens contain several types of information differentiated by foreground and background colors. Default colors are selected to maximize the visual difference between these different types of information. There are 4 available information types on the DLI Control Module screen: green, blue, gray, or black. There is a DLI module configuration link that lists the steps you need to perform to have the DLI module up and running. Follow these instructions to ensure that all the required data is entered and the structure is set up correctly. This page also lists all of the current data for each section. The DLI Control Module is divided into several sections. Each section provides a specific function. The lighting output contains the final result of the DLI Control Module, or the desired output. The desired output is the final result of the DLI Control Module. Automatic or manual setting. Whether the DLI control logic is used to control the lights or if it's manually controlled. Minimum on and off times. Use these settings to control lamp cycling. Try to use the smallest times required by the lamp manufacturer or to prevent excessive on-off cycling. Excessively long values interfere with the operation of the predictive DLI control algorithm. Output timer. Displays the time elapsed since the output changed to its current state of on or off. External override enable or disable. Enables or disables external override logic, which forces the lighting output on or off. When enabled, the desired output is overridden according to the override logic configured on the external override enable screen. DLI cutoff threshold. Prevents the lights from being turned on when the light reading adjusted for transmission is above the cutoff threshold. If this threshold is set too low, it affects the ability of the DLI control program to operate the lamps for achieving the DLI target. With a very high threshold, you may find the lamps operating even during very bright periods if the program thinks it needs the lamps to achieve the current DLI target. Lamp output status displays the current status of the output as a percentage and the highest priority function causing the output to be in the current state. Lighting window. The lighting window determines when the lights can be operated for supplementary DLI and photo period requirements. The window start and end time settings on the screen are for DLI control. If photo period override control is enabled, the photo period window times and light thresholds displayed on the photo period override subscreen are used to override the lighting output during those times. Lighting window start and lighting window end. Enter the lighting window start and lighting window end times. The program uses this to calculate the DLI potential from the lamps. See DLI potential lamps section. The program calculates DLI throughout the day, but it can only operate the lamps between the lighting window start and lighting window end times. The amount of time between the start and end time determines the total moles of light that can be delivered by the lamps. Photo period lighting. There are separate photo period window and threshold settings on the photo period screen. Photo period lighting has priority over DLI lighting. DLI potential, lamps. You can calculate how many moles of light can be delivered by the lamps given the declared output intensity and the supplementary lighting window time. Light source intensity setting. Enter the output intensity of the lamps at the level of crop in micromoles. The program uses this to calculate the number of moles of light that can potentially be delivered by the lamps within the lighting window and the remaining time until the window end. DLI potential, solar. You can calculate the maximum potential moles of light energy at the crop level that can be provided by sunlight, assuming a clear, cloudless day. It uses a linked seasonal light intensity model from a sunrise-sunset table light model control program to generate these predictions. Select the menu entry for light model readings to configure the seasonal light intensity model program linkages. Light model readings. This menu entry displays a screen for setting up the seasonal light model links. These must be configured before the program can generate any predicted DLI values. Total potential sunlight. Remaining potential. Calculated intensity sine curve. Transmission efficiency at the crop. Typically, the PAR light intensity measured at the crop level in a greenhouse can be 50% or less than the intensity measured by an outdoor sensor. Adjusted indoor DLI potential readings. Multiplying the predicted full sun outdoor by the transmission efficiency at crop gives you the adjusted indoor DLI potential readings. These readings display the maximum predicted light intensity, the maximum moles available from sunlight, and remaining moles available from sunlight after adjustment for transmission efficiency and curtain position if used. You can define the DLI target in moles per square meter per day. This value can be entered as a local set point or it can be linked to an external variable if required. When the program knows it has to operate the lamps during the daylight period, it can be proactive, DLI target more important, and force the lamps on, or it can gamble, cost saving more important, by delaying turning on the lamp until the current DLI plus the remaining model DLI and the remaining available lamp DLI are below the target DLI. Don't turn the lights on if within. Enter a percentage value. If the lights are currently off and the current accumulated DLI is within this percentage of the DLI target, the lights are not turned on. The smaller the value, the more accurate the DLI delivered amount. Multi-day averaging setting. When multi-day averaging, it is possible to improve multi-day DLI accuracy by applying any surplus or deficit DLI amounts to the current DLI target. If you want, you can select multi-day averaging for 1 to 7 days. When it's used, any running DLI surpluses or deficits are applied to the next day's DLI target. Light sensors. Each DLI control module has provision for 2 PER light sensors, an outdoor light sensor and a sensor mounted at the crop level under the lights. At least one light sensor is required, preferably a sensor at the crop level. If an outdoor sensor is used, all DLI calculations for the crop are estimates. If a sensor under the lamps is used, all outdoor sensor and shade curtain compensated outdoor readings are ignored. Outdoor light sensor. While it's possible to use only an outdoor light sensor, the overall accuracy depends on the accuracy of the declared light transmission efficiency and lamp output intensity values. The adjusted outdoor light sensor reading displays the current outdoor light derated by the current efficiency percentage in effect. This is an estimate of the light actually reaching the crop. Shade or thermal curtain. These settings are only applied to the adjusted outdoor light reading and are ignored when a sensor is installed under the lamps. If a shade curtain is in use above the crop and there's no sensor under the lights, the DLI control module needs to know its position so it can adjust the solar light predictions accordingly. Curtain open, curtain close efficiency. When a shade curtain position reading is used, these values are used instead of the standard efficiency settings. Enter transmission values as a percentage of the outdoor PAR level for both the curtain open and curtain close positions. Under the lamps reading. An outdoor sensor is not required when this sensor is installed. This is the recommended configuration. When a PAR sensor is used under the lights at the crop level, the program accumulates the actual light values measured from it to determine the DLI delivered. It ignores any values from an installed outdoor light sensor and any shade or thermal curtain compensation settings. This is the most accurate means of DLI control and is the method that Argus recommends. Measured or calculated light at the crop. This value is used for DLI accumulation. DLI Calculations. The DLI calculations display the DLI amounts delivered for the past 7 days and other decision status information. DLI delivered. The total amount of light delivered for today and each of the past 7 days is displayed. Current deficit or surplus. A running fractional calculation and the current day's deficit or surplus is displayed. DLI decision status. The DLI decision status displays the current desired lighting output position and the highest priority reason for the decision. Predicted DLI optimistic. The optimistic predicted DLI predicts DLI based on the DLI delivered and the total potential sunlight remaining. Predicted DLI realistic. The realistic predicted DLI is based on the DLI already delivered plus remaining potential sunlight minus the prediction factor multiplied by remaining potential sunlight times the sensor reading divided by calculated intensity. Prediction factor. A prediction factor setting can be used to weight the prediction towards a more pessimistic or more optimistic prediction. Before adjusting the prediction factor, assure that the following information is accurately configured. DLI prediction is based on the probability that remaining daylight can deliver enough light to achieve the DLI target. Artificial light provided. This table shows the total moles provided by the lamps for today and the past 7 days. Lamp operating times. Length of time in hours the lamps have been in operation for today and the past 7 days. Accumulated copy clear time. This time entry determines when the current day's accumulation is cleared for the start of another day. Normally this is set to midnight. Shutdown and restart settings. There are settings for configuring an emergency shutdown of this control program. It suspends program operations while the configured shutdown condition is in effect. The shutdown feature can be useful to suspend the operations and calculations within programs without losing current values. To trigger the shutdown override, make sure the shutdown and restart settings are enabled. Power restart and shutdown exit. When the shutdown condition clears, or when the Argus controller has restarted after a power failure, it waits for the power staging delay time before allowing this control program to resume operation. Therefore, if you enter different delay times for your controlled equipment systems, you can stagger the restart timing. If the shutdown source reading fails, you can configure the system to either ignore shutdown or force shutdown. Consider the consequences of these shutdown actions carefully. If you're using emergency power generation to hold up selected equipment during power outages, these systems need to be hardwired onto backup power. Always check with Argus before you modify any of the values on the installation and service screens. The installation and service section contains readings and settings not normally required by users. These screens are used for diagnosing problems and other special conditions. The topics we've covered today include using the DLI Control Program, lighting zones, values, DLI Control Module components, DLI Target, light sensors, DLI Calculations, shutdown and restart settings, summary, and a short quiz. Next is a short quiz on the concepts you've learned today. Thanks for watching the video. For more information, see the DLI manual or datasheet, or contact Argus support. Click any of the following links for more information.